Curiosity calls. I'm here to answer. I'm Lady Tanic. Welcome to the channel, and welcome to the question, what space event could destroy civilization? A quick note before we begin. I don't want to scare the pants off of anyone, so please take note that all these events have a very small probability of happening. In fact, the majority of these probably won't happen in any of our lifetimes, if not at all. So, just relax. Let's start with solar flares. Some of you may already be familiar with solar flares, as we had one this year on November 11th. Solar flares are intense bursts of radiation emitted from the sun, which happens when magnetic energy gets released into particles. They can develop anywhere from a few seconds to a few minutes, and they may last for several hours. I'm sure you can imagine that anything from the sun is insanely hot. Solar flares can get up to 100 million kelvins. They're quick too, shooting out at speeds around 1 million miles per hour. The radiation emitted from them travels faster than the speed of light, which is more than 180,000 miles per hour. Although they are incredibly harmful to those of us on the ground, thank you atmosphere, they can have a consequential effect on everything orbiting the Earth. It often disturbs our technology. The intense burst of electromagnetic radiation can throw off high-frequency radio communications, which in turn affects aviation and maritime operations, shorten the lifespans of satellites, causing a massive outbreak of technology problems on the ground, and it can even harm astronauts in space and passengers in high-altitude flights by exposing them to an increase in radiation. But you know what isn't scary? Solar flares are the cause of auroras, or the northern and southern lights. This array of floating colors in the sky is caused by the charged particles of a solar flare interacting with the Earth's magnetic field. So, though they have the power to cut us off from technology, they make cool things too. Solar flares follow an 11-year cycle, meaning there are times of increased and decreased activity. As of now, we are in the ascending phase, which is when the sun's activity is at its peak. Peak activity like this can result in solar storms, which consist of multiple solar flares, solar wind, solar energetic particles, and coronal mass ejections. I bet you have no idea what a coronal mass ejection is, so welcome to the next section of the video. Coronal mass ejections are massive bursts of solar plasma, or in other words, billions of charged particles, and magnetic fields that erupt from the sun's corona. These bursts travel throughout space, affecting multiple planets in our solar system. Directed at Earth, mass ejections can cause geometric storms, or our space weather. It can also result in satellites being disrupted, power surges and blackouts, disrupted radio communications, and once again, increased radiation exposure to astronauts. Coronal mass ejections can reach Earth in just a few days or even hours. However, they are similar to solar flares and they don't have much potential for a lethal end to society. One day, an estimated 5 billion years from now, our sun will expand into a red giant. Though there's no way to know for sure if human life will continue for that long, we'll definitely have a low chance of survival after this. All stars, we believe, go through stages of transformation. Large stars will turn into red supergiants, explode into a supernova, and then have the chance of becoming either a neutron star or a black hole. Small stars, which include our sun, will turn into red giants, then explode into a nebula before ultimately shrinking down to a white dwarf. This is our sun's seemingly unescapable fate, and unless we prevail in space travel or just go extinct, it'll be ours too. When the sun begins to expand, it'll engulf Mercury, Venus, and likely the Earth. boy. Okay. Okay, if I was the sun, what would I do? Oh. Aww. Mars. It's gonna smash right into the smiley face. No. Oh, a car. Hi. There goes Jeff Bezos. The habitable zone of our solar system will move to around Jupiter and Saturn, although the fate of the gas giants in their newly warmed up environment is unknown. For the other planets, it's possible that the new position of the sun could make one of them habitable. However, it's unlikely life would start again as it did on Earth, since just that alone was a possibility of 1 to nothing. Speaking of a star going supernova, what would happen if that occurred near Earth? Well, supernovas are actually thought to be extremely rare. It's estimated that only about 2 stars supernova in our galaxy every century. Like I explained previously, our sun is too small to supernova, so the only way that we'd be in danger of one is if one of our neighboring stars were to die out. And when I say neighbor, I mean more like you live in the middle of the ocean. These stars are light years away from us, but theoretically it's not impossible for one to reach far enough to touch the Earth. If that did happen, it could cause mass extinction. Or maybe just vaporize us and the Earth altogether. I mean, these things put out a huge burst of energy. Supernovas happen when the internal pressure of a star weakens and gravity collapses in on it. It's a little like an implosion, if you can imagine something like the Titan submersible or the K-141 Kursk. A rogue black hole is essentially a black hole that isn't gravitationally bound to any stars or galaxies. They wander around the universe at speeds around 400,000 to several million miles per hour. They can be giant too, ranging from a few times bigger than the sun to billions of times bigger. They're unpredictable, able to sneak up on a solar system and throw them out of their way. If one were to come upon us, the damage would be catastrophic. In the event of a black hole in our solar system, it could go many ways. The Earth may not be affected at all, and we'd watch as the stars and planets surrounding us got pushed around in the sky. If the black hole did come near enough, Earth would most likely be thrown out of orbit. In this scenario, we risk colliding with other planets, getting pulled into the sun, or getting thrown out into the abyss of space, resulting in our planet becoming a lost ice ball. As of now, there is nothing we could do to save ourselves from a black hole. We'd most likely have to accept our fates and watch our world turn upside down. If we survive long enough to watch, of course. Probably the most cliche of the scenarios, there is always the danger of some space rock colliding with the Earth. An asteroid turns into a meteor when it enters the Earth's atmosphere and starts to burn up. If you've ever seen a shooting star, I'm sorry to be the one to break the news to you. A potential danger for us currently is the 2024 YR4. NASA theorizes that it could hit us or the moon in as early as 2030. If YR4 did hit the moon, it could cause a downpour of smaller meteors on the Earth, but the debris would likely burn up in the atmosphere before hitting the ground. And if it happens to hit Earth, it might have the same impact as a nuclear bomb. No worries though. I think we do actually have solutions for this one. We may go the Hollywood way and shoot a few nuclear weapons at it, or most likely we will use the DART mission, which alters the course of an asteroid with the use of kinetic impactors. We could also use a gravity tractor, ion beam deflection, surface alteration. This might have to be another video. It'd be sort of insane to think that we have made our own potential meteors. Except it's not. Because we have. Space debris, or space junk, is defined as any non-functioning man-made object in orbit around Earth. This can be anything from debris that came off of a functioning station or to huge pieces of inoperable spacecraft. There's an estimated 29,000 pieces of debris orbiting the Earth right now, and it has already caused us immense problems. A good example happened to the ISS in 2006. A small, and I mean small, piece of debris hit a window on the ISS, resulting in a 7mm crack. Now imagine if that had been a much larger piece of debris. The damage can be catastrophic. Not to mention, a collision of debris and crafts can cause even more debris, and these things move fast in the void of space. Space junk isn't just a risk to the orbiting stations, it's a risk to the ground as well. Imagine chilling in your backyard only to see a big piece of metal flying towards you. Most debris will likely burn up in our atmosphere, but it's not impossible for larger pieces to make it to the ground and cause damage to our environment, or even us. There have been actual pieces of spacecraft that fell from orbit and hit the ground, only to spill out the toxic substances inside them like fuel residue. This poses a risk towards space exploration as well. Firing rockets towards all the lingering debris is a significant danger to those aboard. There isn't a universal solution to this, but more and more regulations are beginning to pop up to not only reduce the amount of junk, but also the likelihood of a lethal collision. The most powerful explosion in the universe that we know of is a gamma ray burst. They're like the buffed up version of a supernova, and hundreds of times brighter than one, and they come about during the birth of a black hole or a collision between neutron stars. They last from a few milliseconds to several minutes, making them difficult to study, and we first observed one in 1967. To understand how screwed we would be if one of these happened by us, you first need to understand how powerful they are. A gamma ray burst is basically a burst of gamma radiation, the most energetic form of light. In just a few seconds, it can emit more energy than the sun will in its entire lifetime. I read an article about gamma rays that compared their energy to 10 trillion Hiroshima bombs exploding all at once. That's enough to easily vaporize anything nearby. But why doesn't Earth get vaporized each time one of these things go off? Well, for one, we're too far away. Once the shockwave from a gamma ray hits us, its energy has already slowed down too much to do damage. Secondly, our planet's ozone layer takes one for the team once again. Real talk, without this protection, we'd all be extinct in the length of the Titanic movie. So far, there's nothing to worry about, as it's theorized that all gamma ray bursts we've observed have happened outside of our galaxy. Although there is still a lot we have to learn about them, and they may be more unpredictable than we think. Viruses are always evolving, replicating, and varianting, so it's not too outlandish to imagine them finding a way into space. In fact, we may even be the ones spreading them throughout space, which could have any number of consequences, or maybe none at all. But what about non-earthly microorganisms? Is there a chance that viruses may inhabit other planets in our solar system? It's an ongoing theory at the moment. We know viruses can withstand the utmost extreme environments, and if you've seen my last video, you know some microorganisms can even withstand space. Perhaps as we explore planets, we may bring back home our own unwanted visitors, and it's hard to imagine what they could do to our population. There have also been theories as to where extraterrestrial viruses could come from. Maybe they have sailed through space on a rock that came from a planet, or Perhaps they came from an extinct civilization that left them behind, or even they may be a civilization in its first stages of life. Until we understand the true nature and origin of the microorganisms on Earth, the thought of extraterrestrial microlife stays at the back of our minds to be rediscovered at a later time. As we somewhat master the art of space travel, capitalism sneaks its way in as usual. We now send billionaires up to space for a hefty profit, and we're not quite understanding the consequences of this action. Space tourism might literally be the end of space exploration. Sending rockets up to space can sound like a harmless project until you really start to take in all that's involved in it. The most prominent risk seems to be the amount of harmful gases that rockets release while launching. They release things like CO2 and black carbon, which contributes to our global warming problem. Rockets emit hundreds of times more CO2 than a commercial airplane, and the fact that it's becoming a casual tourist attraction is only worsening the situation. For example, remember when Jeff Bezos launched Katy Perry with 5 other girls into the edge of space? That mission resulted in an estimated tens to hundreds of tons of CO2 emissions, and that was before the rocket was even launched. The exhaust from a rocket is also destroying the ozone layer, which you should know by now is literally what keeps us alive. If that wasn't bad enough, more rocket launches mean more space debris. So whilst we're trying to solve that problem, we are simultaneously making it worse. There's a theory that one day the universe will stop expanding and eventually collapse in on itself from the force of gravity. This would result in the universe heating up, galaxies and everything in them colliding together, and everything suddenly turning into nothing. This is the Big Crunch theory. The Big Crunch stems from our little knowledge of dark matter. If dark matter were to slow down somehow, gravity will win over and pretty much turn everything into a pancake. There is a chance that after the universe is turned into a pancake, the Big Bang will happen once again and a baby universe will be born, beginning a new cycle of expansion. No worries though. As far as we know, the universe isn't slowing down, it's actually speeding up, meaning that dark energy is dominating. Well, okay, maybe one worry. Opposite of the Big Crunch, the Big Rip is the theory that if dark energy becomes stronger than anything in its path, it could expand the universe so violently that everything in it is literally torn to shreds. This would result in the entire universe becoming unstable, unpredictable, uncontrollable, and it may even begin to disobey the laws of physics as we know them. Again, just a theory. There is no reliable proof for aliens. But if they are out there, do they pose a threat to us? The answer is most likely not. I know we all want to think of aliens as the green, ooey gooey monsters that like to stick things up people's butts. If there is life out there, it's most likely microbial. Complex life, like here on Earth, can only occur when a series of very improbable events happen and continue to happen through evolution. At least, this is what we think is right. Even so, there are still a few silly alien theories that we can go through. One is that there is other intelligent life, but it's intentionally avoiding us to ensure we develop naturally. Or maybe they're just observing us for their weird hobbies. Another is that there are multiple civilizations, but they are all hiding away to avoid the dangerous and feral populations. There's also that they are just too far, or not intelligent enough in technology, or maybe that they are just completely different beings than us and can't connect with us in any way. Aliens may be unlike anything we've ever seen. They may hold power that we couldn't even dream of. They may hold knowledge that we couldn't imagine. It's truly a big guessing game of what would happen if a civilization reached out to us or dropped by for a visit without warning. There is still much left unknown about the universe. Theoretically, anything could happen at any given moment, and we may only have seconds to react. Even our very lives are unknown. Our origins can only be speculated, as can much of our surroundings. Perhaps in a future video we'll research some of the mysteries of space. But for now, thank you so much for watching, and I'll see you in the next one.